Okay. Good morning, participants, and we are about to start. I'm giving you 1 minute for those who haven't joined so that we can start. So 1 minute, a few seconds left. Thank you. I can see people saying they're enjoying the sessions. Link for day 3 should be on the Google Drive. And it was sent to your mails if you registered. It has been pasted in the chat. Please pick it as soon as possible before it disappears. Okay, now we are going to start. I'm going to share the PowerPoint that we had yesterday. Okay, so before we went to the script, to the R session, we looked at experimental design sheets. We looked at survey. The most important response that I saw there is that people appreciated that I talked about the coding, multiple response, how to capture the data, how to organize the spreadsheet for experimental design and survey, and that was really good. So from there, we are now coming to R. So what we are going to do in R today is to learn how to design a field sheet for an experimental study. And then after that, we are going to do some descriptive and plots that are related to experimental design data. So I'm just perusing through this. Okay, there we go. So I am hoping that all of you have the notes, the PowerPoint, because it's going to be practical most of the time, if not all the time, little theory today. And we had an example here. We want to design a field sheet, and this researcher would like to investigate 3 times of raising bread. This is an example from the food science section. And this researcher had 3 treatments, 35 minutes, 40 minutes, 45 minutes, and replicated 4 times, giving us 12 loaves of bread. So this researcher used a complete randomized design because we are not mentioning blocks here. He assumed that all the ovens had the same variability. We could control the background information. That's why they chose a complete randomized design. Now, for us to be able to do the R code, to be able to produce a field book, which is going to be important in collecting this data, we had this script here written. And the first thing we talked about is setting a seed. The seed is set so that you get the same random design every time you come to run these commands. If you eliminate set.seed, then you're going to have a different randomization every time you run the commands in R. And the number in between there, if you have seen a random number table, you can start anywhere. So I chose to start from 7,638. So you can put 78, you can put 770. It does not matter. It's not really so much important where you start from. So long as you're telling R, you want to do a randomization and you want your design to be the same. Okay, the next row, we assign an object X where we are going to store the factor time. And we are going to replicate it. The second rep is replication. And then put together the times 35, 40, and 45. Each equals 4 is the replicate. Then we close the brackets. So the function factor creates a vector of the factor levels for rising time and stores it in a variable X. Then when we go to bread, the function sample randomizes the order of the factor level and stores the randomized vector in the variable bread. Y is a list of values for the response. Y goes from 1 to 12 because we have 12 loaves of bread. Object rise, we use a data frame to merge together the vectors X and Y, and then label Y as loaf and time equals bread. Then, so that's what the data function, the data.frame function does. Then we write our rise on a CSV file so that we can open it in Excel. So that is the last part of our commands. So there's write.csv. Rise is the object in the former command. File, now you're giving a name of the file. You put it in quotes, rise.csv. Row.names equals false. Okay, then head is used to print the first 6 rows of the data. Okay, so we are going to, so the next slides explain the same thing that I've been talking about. And yesterday I said that remember to quote the source where you've gotten the information. Okay, so we are going to do this in R. So I'm going to flip to R. I'm going to stop the presentation. Can you hear me well? Do I need to repeat anything? I'm going to do the same thing in R. Let me check the chat. Okay, they say yes, yes, yes. Thank you. Okay, thank you very much. Excellent. Okay, I'm going to change over. So all of us, let's open R. Let's go to R. And we open our script. It's called XP Lab 1. I sent it in the training material. Remember, we are going to go through with this with you people, and then there is an exercise after that for you to work on, and then I'll randomly select 2 people to show me that they've learned what I have done. Okay, so everybody should participate. Okay, so I'm going to open R also. That is my R. Remember, before you run any script, you have to load. I've not shared it. Oh, okay. Yeah. Okay, so is this visible? Is the R window visible? Okay. Okay, so what I was saying, that the first thing we do, we load the packages that we need to use. I've already loaded mine. So the most important packages we need to use, we need the ggplot2, We need Gigi BUR. Then we need the deployer. We need Agricola. So I'm going to select them so that you see the packages that we need. So those selected in blue are the ones that we need. If you do not have them installed in your R Studio, you can install them using the knowledge that Dr. Helen showed us. So this one is going to test whether you people have been following. So please install ggplot2, ggpubr, dplyr, Agricola, and Dua. So install those ones. Let's take off 3 minutes to do that so that everybody, we are the same page and we go on explaining the things. We need those packages. Please do that. And let me check the chat in case somebody has a problem. Okay, somebody says they have a challenge setting the directorate. Okay, can you now pay attention? Go to session on top of the R Studio menu. Click session. Then you will see set working directorate. Then choose directorate. Are you there? Okay. Then click choose directorate. Then you go where your folder is that you're going to use, where you're saving your R files. So I'm going to click documents. I look for R and then go to slides. That's where my work is. Then I click open. So in the console, you will see set working directory and you'll see the route, the path. Okay, so once you see that, you know that you've already set your working directorate. Okay, so we have 1 minute to install the packages and load them. Remember that library ggplot is for loading. Then if you want to write the command for installing, you use install.packages in bracket, the name of the package. Okay. So if you finished installing, can you type a yes and loading? Type a yes in the chat so that we can now start. Somebody says not yet. Okay. Okay, most of you are saying packages loading. The other thing somebody has asked about the package which reads CVS files. You have already installed read R and also read XL, so you just load them. Okay, so on top of the others, you can load Learner R, read XL, and read R. Okay. The name of this file, the script is exp lab b1. Let me type it in the chat. Yes, somebody, you didn't receive. Sorry about that. Where are you? Okay, is that you? Dr. Helen has just posted the script in the chat. And she's going to also post it in the Q&A, so you can pick it there. If you do not have that file, we need it. It says it's hidden, so she has posted it again. And we also need a file called forest. So she has also sent. Okay, so somebody says they need to see the packages very well. I think you can type them in the chat. Okay, let me just copy and put them in a Word document. Oh, no. You've put them in the chat. Okay, Dr. Helen has pasted all of them that we need in the chat. And I've mentioned Learner R, Deployer, Read Excel, Reader, then Agricola, Doer, ggplot2, ggpubr. Okay, so let me see in the chat if you've finished so that we can go on. So just say yes, yes, if you've loaded so that we can save on time. And if you didn't receive the script, just follow what I'm doing and you keep doing it. I think you'll also learn. Somebody says still loading. One minute, one more minute. If you have a problem with Due, Agricola is refusing. Some people are saying they have a problem with Due, they have a problem with Agricola. What you do, close or restart your laptop and then you reload them. If Agricola refuses, restart your laptop and reload or install them afresh. And make sure you have an updated R version of 4.1.1. Okay? Agricola is large, so might take time for some people. No. It takes only actually 1 minute to load. If it is taking long to load, then it's the internet, not actually the size of the file. Okay. Okay, let me see if you finished. Can we see yes? I'll give 2 more minutes. At 11:30, we are going to start. I don't want to start and leave most of you behind. So at that time, let's start with remember, install, you have to put the quotes in the bracket, not outside the bracket. Okay. Now, if I've made a mistake in the written script, you can always correct me. Sometimes I use the install command. You know, there is install in R Studio. If you go to packages, you can you see my cursor, participants? If you see my cursor under packages, if you click packages, you will see install. So you can also use that. So I'm just, those who are stuck with install, click packages in the lower window, which is in the right bottom corner. So click packages on that window. You will see install, and you see something, a dialog box like this coming up, and then type in Due. Okay? Once you type in, you'll also see that actually it exists. It just needs to be, installed. Then you click install. Okay? So that's the easiest way if you don't want to write the commands. So are we good to go? Can we go on? My 2 minutes are over. Okay. Okay, can we see yeses coming up? It's working, beautiful. Okay, go on. I can only see 3, 4 yeses out of many people, please. Can I see that you are okay? Because when I start, I'm not going backward. Okay. Okay, so I'm going to start. So we said we had an example in the PowerPoint, and this is where I've put hash experimental design, generating field datasheet using CRD. Are these notes visible? The ones written in the script? Can I see yes? Because we need to see them. If the notes are visible, let's see yes. Okay, thank you very much. Okay, you can see that my first line says set.seed 7638. And then I have a comment, randomly generate the data using ... Okay, that's just a comment to remind me what that line says. So we also talked about X is the object and it's a factor. It consists of the factor, which is time of rising of bread, and it's going to be replicated 4 times. So let's start by running each command. So we are going to run set, put your cursor either in the middle of the set.cd command and click run on the menu here. Run is at the top menu of R Studio. So click run, and below in the console you will see that it is blue in color, meaning it successfully has been executed. Then if the cursor moves to X, click run to. If it doesn't bring red, then you're good to go, meaning it's working. Anybody who has a problem at that bit? Okay, somebody says yes, they have a problem. You have a problem, but I don't know the problem. If you send you have a problem, write the problem that you have, because I'm checking in the chat as well. Okay, so if you have a problem at this command, please let me know. Did it bring red? What was the error message? You can just please enlarge R. If you do not have these commands, you can type them in the R script. You just have to type set.seed and the number, and then you click run. So I'm going slowly so that those who don't have the script have time to write it. Okay. Now I'm going to run bread. Bread is an object, and it's where you're storing your your randomized treatments, that is time of 35, 45. So let's click run at that command. Sometimes if you want to see what is happening as you run the commands, you can actually put your cursor at the end of that line, enter, and you type bread. So if you type bread and run, you will see the data. Okay? So you just want to see what is R doing, because you're seeing commands written by me and you don't know what it is doing. So you just enter at the end of this command where my cursor is, then you type the word bread. So let's go to the next. Y assign 1 to 2. That is your response. You're assigning experimental units, which is bread, 1 to 12. So let's run that. I'm too fast. Okay. Okay, let me go backward. I'm going up to X. Most people are saying I'm too fast and I don't want to leave anybody behind. Okay, at X, please run. Click run. Click run, and there we go. Remember, I said the function factor creates a vector of factor levels for rise time and stores it in X. X is the object. Then we have bread. So the ones which have been stored in X are now going to be randomized by the function sample and stored in an object bread. Now let me run bread. Now bread has run. And if I want to see what is in bread, I just click at the end of the line, the command which I have just run, and then I write the name bread to see what R has done. So at bread, I click run. And then it will show me what R has randomized your time, 40, 45, 35, 40, etc. Ladies and gentlemen, participants, we are not using any data. We are generating a field sheet that you're going to use to fill in your data when you go to collect data. We are telling R we have 3 treatments, 35, 40, and 45. We want to randomize them, and then we want them allocated 12 experimental units. So what R is doing, it's not producing data, it's producing a field sheet because we are at design stage. Okay? Is that clear now? There's no data here. You haven't seen an Excel file written now, but soon we shall see. Okay? Okay, the next line, I'm assuming now everybody's fine. Let me see the chart. The chart says, okay, clear, fine, great. Okay, the next line says Y is the object, it is the response. Equal or assign values 1 to 12. So let's run that. You click run. Once it doesn't show red, then you're good to go. Now, the next command, I'm creating a data set with the name rise. In R, we call it an object. So rise is where I'm going to store my information about the treatment and the response. My treatment is X, and I've named it bread, and my response is Y. But I'm going to give them names so that when I'm collecting data, I know what I'm doing. So rise is an object assigned or equal to a data frame. Helen talked about the data frame, what it does. It's going to merge the vector Y and bread, which we've already generated above. So at rise, click run. Now, after that, rise is in R, but I want to see my rise in an Excel worksheet. So I'm going to write rise in a CVS format. So I use the write function. So you can see write.csv, and in bracket you will see rise, comma, file is equal to rise dot. So now rise.cvs is the file I'm creating. Row names dot equals false. So I want us to use our names in rise, okay? So let's run that function. So after that, you can now find out what your rise consists of. Okay, some participants are saying I'm so fast. I will go back to rise a little bit, but also follow me so that we can do a lot of work in a short time, because we want to give you as much as possible so that you can benefit. So let's catch up, okay? Okay, so I'll go back up to rise. So we've said that in the first 3 lines, we've created our factor, which has the treatments. The treatments are time, 35, 40 minutes, and 45. And we have randomized those times to avoid bias and stored them in an object called bread. Then we printed out bread. But we need a response. So we've written another line called y is equal to 1 to 12. Remember, we replicated 4 times. The treatments are replicated 4 times, meaning if there are 3 treatments and we multiply by 4, we are going to get 12 treatment units. And those are the 12 loaves of bread. We are going to subject the 12 loaves of bread to a randomized treatment of 35, 40, and 45. The result of these commands is not data, it's going to be a spreadsheet in experimental design. Are we okay? Then let me see in the chat who has a problem. Okay, in 1 minute, write your problem and we see if you're okay, write okay. Okay. Can I have more responses? Okay, okay. 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 Excellent. Okay. After randomizing your treatments with this sample function, you are randomizing your treatment. Why do I go through this step? I'm assuming that you're going to go to the field. You have an objective. You know what you're going to do. You are going to perform an experiment. You want to have an organized data sheet. This procedure here helps you to create a data sheet you're going to use to collect data. So when you come to enter your data, it's already organized. That's the main aim of going through this part, okay? So at Y, we are specifying the response, and the responses will go from 1 to 12. After specifying those 2 things, bread and Y, we want to write them in an object using data frame. What the data frame does, it combines the vectors bread and Y as columns that are stored in the object rise. So we write rise, assign, which is the same as equal to a data frame, that is a function, in bracket, loaf is equal to Y. Those are the names of your response, and time is equal to bread. You're telling R that pick the treatments of time in the object bread, and also pick information of the response in the object Y. So you write them using data frame, join them in 2 columns and store them in rise. Then we want to be able to open and print your rise in Excel. So we go to this write.csv, rise, comma, our file is equal to rise.csv, comma, rows equals false. So when you run that, then you get an Excel file or CVS file. And head, remember, Helen says it prints the first 6 values of your field sheet. So I'm going to run at head, and you can sit down in the console. If you run yours, you will see LOF 1 to 6 and then time. But now you can go to your folder and open your RISE in Excel. And then you can do a lot. You can add another column, subtract, whatever you want to do. Okay? So let me see in the chat. Is there anybody who has a problem with that step? Somebody said set seed. Set seed, as I said, it just helps you to tell R that you want to generate a design and you don't want it to change. Okay? So if you do not want to put set seed, then everything you're going to generate will be different. From today, if you generate tomorrow, you get a different setting. If you generate the next day, you get a different setting. So you want to have the same design today, tomorrow, etc. Then what about the number? I say that this is a random number. You pick. Yes, we can change actually. Let's change this number here. People are complaining about this number. Even me, I was puzzled by this number. Let me put a 9 instead of 38. Let me put 39. Now, when I put 39, the randomization is just going to change because I've said now I want you to start at 7639. So if I run that, I'm going to run this very fast. You can also do it on your laptops. Instead of 7638, change it to 9, or we can say 40. Let's do 40 so that we even change it completely so that it helps us. So we do run, keep running, running, running. There we go. There you see. You have a different randomization from what you had before. So that number is a random number you pick from a random number table. You're going to see that in the next thing we are going to generate field sheets, they are going to be totally different. Okay? So if you are in R and you see in the environment section, you will see RISE, the spreadsheet RISE. Click on RISE. We want to see what RISE has. So if you see that I have shown you RISE. Okay, so you see, this is now my spreadsheet. You have LOFs, those are the LOFs you're going to have, and time is the treatment. Now, if you take this spreadsheet to Excel, you're able to add another column height and another and print out, and you go to your lab and enter your data. So this is not data, ladies and gentlemen. It is a spreadsheet, an organized, randomized spreadsheet, which you're also going to use in setting up your experiment. So when you go to lab, LOF 1 is going to be subjected to 40 minutes of rising. LOF 2 is going to be subjected to 35. LOF 3, 35. LOF 4, 45, like that. So this is randomized. So instead of you going to use the random number table to randomize your treatment, here R has already randomized the treatments to the LOFs, which are the experimental units. Now, if that's clear, I want to answer questions in the chat. Somebody says they can't see object RISE. Where in the PC is right? Go to your folder where you, okay, let me answer this one. Okay, ladies and gentlemen, participants, you have a folder where you set the directorate to. You go to that folder. Now I'm going to do the same thing. So I am going to stop sharing because some people are saying, where is RISE? So stop. First of all, RISE is here. Under our studio, you can see RISE. Can you see my cursor? The hand, do you see the hand? It is pointing at RISE and environment. Okay, So if you click in it, it shows here in the where the script was. It showing you the LOF, which is the experimental unit, and time. So if you have an agriculture experiment, this could be the plot, and then the treatment, fertilizer. And then you're going to add another column called height or yield in the Excel. Now somebody said, where is RISE? RISE is in your directorate. Okay, so I'm now going to the directorate. You see the folder there? My folder is called slides, and I'm going to look for RISE. You see RISE is right here. I don't know whether it's visible, but I'm going to click at RISE, and it's opening in Excel, ladies and gentlemen. Okay, you can see RISE. Let me make it bigger, RISE. Have you seen RISE? It's in an Excel worksheet, no longer. Have I shared? Is it visible? Okay, let me share the Excel. Okay, sorry about that. Let me share Excel. So RISE opened automatically in the Excel worksheet. Are you able to see it? Let me see in the chat. Is everybody seeing the RISE? Okay, excellent. So it is no longer in the R script or R Studio. It's now in Excel. Here we can now put height of the bread and add other things you want, color of the bread. Color, when you're doing your experiment, you have so many things you're collecting. So you have color, so here we have height, and then you can save it and take it back to R to work with after you've collected your data. So this is not data, this is just a spreadsheet, and it has helped you to randomize the treatments to the experimental units. And what you're going to do is to perform your experiment in the lab, collect the response, and now you're good to go to analyze your data. Okay, can I see if anybody has a problem and we sort that problem? Okay, somebody says it went to documents. If you've not, and then about the seed, okay? Now, if you've not set the directorate, then it's just going to go anywhere. So please set your directory to that particular folder you want. So let me stop sharing R and we go back, Excel, and we go back to R. Okay, so if you want to remove the spreadsheet you see from the R Studio, you just go up here on top. You can see RISE with an X, exit out and back to your script. So on top here, one thing I want to tell my colleagues, ladies and gentlemen, that please do not fear R. I know when you've just started using R, you have a phobia that if you type in X, you're going to get a red mark. And so it blocks your brain and you can't even understand anything. But just go in and say you will do it and it will happen. Okay? So even if you get a red mark, don't fear the red mark. Just highlight it, take it to Google and get a response there and then. Okay? So let's have that determination of learning R, and we are going to learn it. Okay? I have that experience that if you're in R, you don't even want to change the command because it's going to bring red and you don't want to see any red. No, we also receive very many reds in the console. But what do we do? You just copy the red, put it in Google, and Google is going to give you a solution, okay? So all of us, let's have that determination to learn and remove fear in our hearts, and we are going to excel, okay? Everybody should leave this. After 6 days, you should at least be able to open a file in R, export, import, do some summary statistics, generate a field sheet. We do not want you to go without anything. So I have seen that some of the question is out of fear. Okay, but let's remove phobia of R. Now about the seed, this is a random number. If I had a random number table, I would show you. It starts from 10,000s of number. It has 4 digits, 5 digits, 6 digits. So you can choose anything. Okay, so in the next example, we are going to choose a 3-number random number, and we see what is going to happen. It doesn't matter what you choose. But I have an exercise for you, guys. I'm going to give you only 5 minutes. So if we go back to I'm going to stop sharing this. Once more, I want to find out, is there anybody with a problem before we go to another part? Anybody with a problem, say yes or no and indicate your problem. If you say yes and I don't know your problem, then I can't know the problem. Can I see more responses? Error. Okay. Okay. Installation failed. Oh. Okay, so I'm going to answer a few of them, and some of them we can answer them as we generate the next field sheet, the exercise. So somebody is still asking, what is the use of seed? I've told you this seed here. It is a command you're telling R to generate a design and make sure that design doesn't change. Now, if I remove this seed, so I'm going to remove it temporarily. I'll put a comment so it becomes inert. So the seed, I'm going to start as X factor. If I remove actually, even instead of that, let's just remove the number because this number is bringing problems. There we go. So we just put empty, okay? So when you don't put a number, it is going to generate the design randomly, but every time you come to run that same command, you are going to get different randomization. So assuming that you run what we've gotten, you've saved it in Excel, and then your computer gets corrupted. So that means you've lost the field sheet you generated yesterday. So you come today and you don't put the seed, you're going to get totally different things. But remember, you went with that field sheet and set up the experiment. So you've set up your experiment with the random number you generated in R. It's no longer anywhere. You can't see it because the computer has been corrupted. So the most important thing with the R seed is to make sure that every time you run the command with the same seed, it's going to give you the same randomization. If you don't put anything, let's run this and see. You see, it's saying error in argument, missing with no. So it's saying there's something missing. So let's put another number, 77. We are putting 77. Yeah, 77. Let's randomize. I hope you're following. There we go. You see, I also got red, but I wasn't scared of the red. So what I did is to put a different random number. And then I generate. It is not refusing to work. Generate. There we go. I'm fast. Error. There we go. Another problem now, you see. Error in file. If else append that, in addition warning, cannot open file, permission denied. Okay, let's go back and see. So what I'm going to do is to go back. I run the seed and run the factor. We've set I'm assuming that you all now understand what I'm doing. If you don't understand, raise your question. Helen will capture it and pass it on to me. And then I run bread is running okay. We've generated, you can see that when we used 77, the first random seed, the first number was 40. Now you see, the first number here is 45, 45, 30. You see the difference? So that is the use of the seed. So when you change, you get a different randomization. Then you click Y, okay. Then we go to raise, it has run, then write, okay, permission denied. Huh? Which package? Let me call this rise maybe, oh, the package, okay. Let me see with my packages, Agricola. Okay, then Dua is fine. Read XR. Dipla. Okay. Read R. That's it. Tidyverse. Okay. So what was I doing? I got a problem. There's no mistake in the code because it's what we've used and performed successfully, but probably I hadn't loaded some of those packages. So now it is bringing a problem. So let's go back and run. Set the seed. Okay. X. Okay. Bread. It runs. Print bread. You see, it's bringing the same randomization because you've set the seed. Then let's do that. Run. This one successful now, right? Okay. Error in the file. If else connect. Cannot open file, rise, permission denied. Okay, probably let me name it with a different, let me call it 1. And also here rise 1. Probably it is open. File rise, it's open in Excel. So I'm going to run again. So you can see that when you get a problem, you try to solve it with all different ways. So I'm running again. There we go. Rise, okay. Okay, let me see, rise 1. They are successful. Now the problem was that rise is already open in the worksheet which I didn't close. So it was communicating to R and saying they want to create rise, yet rise is open. So it couldn't run. Okay. Okay, ladies and gentlemen, is that fine? Is there anybody with a problem in the chat? In 1 minute, can I see? Yes, I've run everything to fix the problem. Okay, let me see if you have a problem. So, ladies and gentlemen, even us, we get those red things, as I said, but you see how you solve the red, you don't panic and give up. Because even if you give up, it is yours, it's your PhD, so you have to finish it, okay? Yes, so we have to be strong. Okay, great. Now, I want you, ladies and gentlemen, I'm going to stop sharing this and then share my exercise. Okay, there is the exercise. And I'm going to give you 5 minutes so that we do, there is the exercise. I'm going to give you hints in an experiment to compare growth of mahogany species, 6 plots of each of the 4 species. So species is treatment. There are 4, A, B, C, D, were grown The plots were allocated to the species in a complete random manner. That means that is a complete randomized design. There are no blocks. Using R command, design the field sheet for this study. So let's have you do this in R so that you learn. If you don't do an exercise now, after doing this, I'm giving 5 minutes. If you finish it, then whoever's done it, whoever goes up first in the chat, whoever says I'm done, will show us how they've done so that you know that people are understanding and it's doable. Okay, ladies and gentlemen. So we have 4 treatments replicated 6 times. So it's the same design. This time there are 4 treatments and replicated 6 times. Okay, this is a joke. Most people say that teachers teach the simplest thing and then they set the difficult ones. This time I've set a very simple one. That they say 1 plus 1 is 2, then they say x plus 2 is equal to 3. Then they say find x. You see? But this time, this is straightforward. No tricks. 4 treatments replicated 6 times. Okay. You have 4 minutes. I'm back. Okay, ladies and gentlemen, we have 2 minutes to complete this exercise. I think I can stop sharing the PowerPoint and go to R. Okay, there we are. We have 1 minute to be done. Anybody who is done, they can say yes in the chat and they'll be the first to present. Z equals factor rep. And he has an error. Can you answer that? He needs quotes. He needs If you have a problem, please put it in the chat. I mean Q&A, so that is easier to capture and doesn't disappear very fast. Here in the chat, let's be answering yes and no. Okay. So here William says he has done. William Makazi says he has done. So William, you're going to show us what you did. So I'm going to call David, if he's around, to allow William to share. So I'm going to stop sharing. George also is done. So let's have William first.
William who?
William Makazi.
William Makaza. Okay.
Makaza, yes. Okay.
Okay.
Let me stop sharing so that you can share, and I will mute myself.
Okay, so William is now with us, so he should be able to share his screen and unmute himself.
Unfortunately, sir, I cannot share the screen. I'm connected using my cell phone.
Okay.
Yes, maybe you can pick somebody else.
So, Prof, you have heard from William?
I have heard from William. Let me see in the chat. The next person. Let's have Dennis. Let me go back. There is a next person here after William. Oh my goodness. We have
Prof,
George.
you can also ask them to raise their hands, okay, and then you can choose randomly from the raised hands.
Okay, you can raise up your hand if you're done. Raise up your hand if you're done so that we can choose. There is Dennis here in the chat. It says done. Dennis, can you share? Or Vincent, there's also Vincent Senfuka. Let's have Vincent Senfuka to share. Vincent,
okay,
can you share?
Let me allow Vincent.
Okay, allow Vincent to share.
Vincent. Vincent, please go ahead.
Is Vincent in? Please, time is running out. We need you to share. You put done.
Yes, he is in. Vincent, please go ahead. Unmute yourself and share your screen.
Vincent, you've muted, so unmute yourself. Okay, thank you. Now you've unmuted.
Hello. Are you hearing me? Hello? You're hearing me?
Yes, yes, we are
Yes, we
hearing
can
you.
hear you.
Please go ahead.
Share.
So, okay. How do I change it?
Go on your lower screen, there's a word share screen, and you click that. Then after that, you will see the R window, then you click on it and say open or share.
Okay, so do you hear me now?
Yes, we can hear you. Make it larger, a bit larger.
Let me see. Can you see it now?
Yes, we can see your screen. So show
Okay.
us where you started from.
Okay.
Okay, put a cursor where the other part ended and create space between the X factor so that we can see clearly.
Okay. So first of all, I first created the seed.
Okay.
I created the seed, which is 7638.
Mm-hmm.
Then I created the X factor, which had the treatments, which is A, B, C, and D. So, and then of course, it was there were 6 plots. So that's why I gave them 6. Then I had to make the vector. Oh, is it the factor? Is it a factor?
Okay, Vincent, for each line, keep running. So go back to set seed 7683 and run. Okay.
Okay.
Yeah, run. That's it says error. Yes. Do you know why you have an error there?
No.
Your treatments are now categorical. So you need inverted commas. Go to A and put in those quotes. Put the quotes there, yes. Put A inside the quotes, yeah. For
I put
every
all the
letter,
numbers.
yes, all of them. So you should do that for every, and put a, yeah. Okay, I hope everybody is seeing what Vincent is doing. Okay.
So I can run now.
Yeah,
Okay.
you run it and we see what happens. So it's working well, isn't it?
Yes.
It says, okay. You can call it
Okay,
another
then
name.
I can
Call it Y. Enter and call it Y. Or call it Z, whichever name you want to call it.
Then I can run.
Yes.
Of course, they're going to make 24 of them.
Mm-hmm.
So I'll run this.
Mm-hmm. Then go and yes.
So then I'll go to the rise.
No, have you run Y?
Yes.
You run Y
This one.
first.
Oh, okay.
Then rise, call it maybe rise 2. So you avoid using the same names if it is your own work, because then it's going to replace your work. So call that growth. Call it growth. And call that instead of, then remember you called that time, call it species because it's no longer time. And the time is Z. No, actually species is Z
Okay.
and time is species. Okay, that is species. And species call it Z. So hopefully people then run that.
Error.
Okay.
I'm seeing an
Then
error here.
you got an error?
Yes.
I can't see the error. Scroll down.
I see
Scroll
an error in
down.
my
I can't
console.
see your error. In the console, I can't see the error.
Maybe
Go down.
is here. Error in data.frame.
No, you go in your console and scroll down. I can't see the error.
My screen has gone down. My screen is down.
Okay, let's look at
Maybe
your
okay. So did I
rise
miss
to
any inverted
data
commas?
frame. Growth equals Y and species equals Z. Okay, that is okay.
Then this
The
time,
Z you have on the second line is capital and the Z you have here is small z. Okay, they should all be the same. Yes, and you should rerun because now it doesn't know what you did. Go back and run. Okay, run that.
Okay.
And then
I
run the
run
next.
this.
Run Y.
And now,
Everything's okay.
yes, it's okay.
Okay, then call
So
rise, change it to rise 2. Go here in the right. Yes, remember it's called rise 2.
right.
And this one, call it also rise 2. Okay, then run.
I can run now. All right.
Yes. Okay. Then go to head and call it rise 2, not rise. Okay, run it. Okay, so you can see that now rise to, if you go to the environment section, go to the environment, you can see environment very quick. Environment rise to. You see rise to in the environment?
Yes.
There, click it.
Yes.
Click it. Click twice. Can you double click or click once or twice?
Yes, it's loading now.
Okay. So we just want to show other participants that this is doable. Where is it? Going forever? Click in it again. Click on rise to.
I think it's coming. It's just that
Oh, rise to, I can see it here. Yeah, it is loading. It is taking forever. There you are. There you are.
Yeah,
So
it has come.
you can see that a sheet has been generated and we have species going on. So you can take it to an Excel worksheet, print it out, go to the field and collect data. Okay, so you can, thank you so much, Vincent. You can stop sharing. I hope this has helped others to solve their problem. Please stop sharing.
Thank you very much.
Time. Okay, John, thank you. He says mine works well. Is there anybody who has a problem writing that code? Okay, I can see in the chat you're saying okay. So let me see, I have the same display, but randomization is different. Great, and did you get the output? Okay, Vincent, you can mute yourself. And I'm going to, okay, so I'm going to share my screen. They are saying successfully. Let's look at the chat. Okay, more comments. Mine also works well, great. And those with different random numbers, are they working? Mine at Z, it showed me the sample large. Okay, so let's share my screen. my R screen. And those people who got this R screen, actually the command is just down here. So that's how the answer is right here. But of course, I didn't expect you to see it. So the answer is right there. You can see that it is the same thing we've been generating. The seed this time is 7639. And I said S is the object. Factor randomize ABC. The ABC, because now they are not numeric, we put them in quotes, okay? Replicated 6 times, 4 sample S, 24, growth, forests, data frame, growth. Okay, so we've gone all through this. So it is right in your R script, so you can run it later. Let's go for something else. Okay, there's also another puzzle which I would have given you to run, but let me do it so that I become a good teacher who gives you only simple things. Huh? Okay, so what if you have unequal replicates? You don't have enough funds, but you've decided for treatment A, you replicate 4 times, B, you replicate 3, and C 4 times. So we have unequal replicate, okay? So we write the same randomization. You can see now here, I didn't set my seed, but I can put set seed. In bracket, I'll put 7889, okay? Okay, so we are going to generate a field book with unequal replicates. So when we go to collect data, B will only be replicated 3 times, and even your field experiment has B replicated 3 times. So we run that. I hope you guys are following. If you do not have the script, write the commands and we go on. So because my treatments are ABC, I have those quotes, replications, okay? Now I've changed, I've put in R design. Now, do you realize that I have here design.crd? This is a function that is telling R to make a complete randomized design, and it's only library Agricola which does that. Design.crd. So I'm telling it to design this experiment of mine, and you can only pick those commands if you've loaded Agricola. Okay, then when I run that, you can see that R design, but let me have the book printed out, and then I do head book. So when we look at the book, you can see it has plots, it has R, the replicate, it has the treatment. And you can open this in an Excel file and then print it out with extra columns for filling in your data. So that is the importance of designing a field book in R, to have randomized treatments to your experimental units, and to have a well-organized spreadsheet that you later enter your data in. Somebody has said, what if I use Excel? Why do I have to bother with R? But I think people have benefited knowing how to design a spreadsheet in R, which you can use to collect data. So you can always use what you feel is comfortable, so long as in Excel you can randomize your treatments, you know the function for randomization, or any other package. Okay, no problem, so long as you're comfortable, but you can run from one package to another depending on the need. Okay, any question? Let's see the chat. I can see so many comments. Let's see the chat. Please repeat. Okay, please repeat. Okay, let me repeat. Unequal replicate. So I'm going to X this out. You see on top here where my cursor is running, there is book. I'm going to X it out, and then my commands come back. Okay. So there we are. So we are generating a CRD. CRD is complete randomized design. Remember, it is a type of experimental design where we have homogeneous background variation. We don't have anything disturbing us. And that setting can only be got if you can control the background information. So it can only be done in a greenhouse or a screen house, etc. Don't do that in the field because I don't think the field is homogeneous. Okay, let's go on. That's just a point to note. So for us to generate a field book for CRD with unequal replicate this time, remember the other time we had equal replicate, 6, 4. Now, Jesus, okay. Are you still on? I can see I'm still on. Okay. So if it goes off, we've had some power out. Power's gone out, but we hope everybody is able to see. Okay, so I'm going to run the first command, which is set.seed, and I set my seed at 7889, different number from what we've been using. So I run that. So the next one is TRT. I'm telling the R that I have a treatment, and I want you to put together those treatments. They are called A, B, and C. So I run that. The replications are unequal, so that's why I'm telling R replications equal to, put together 4, 3, 4. So I run that. And then I'm saying that I'm going to store all the above information in an object called RDesign. And RDesign assign or equal to design a CRD. Now I'm bringing all the things I've done above. TRT we've already specified. R is equal to replication. We've already specified replicates. The seed is equal to 7, 7 wherever. Now here I put a different seed. I can actually change and put the same seed as I used above. So seed 7889. Okay. Let me see what is this way. So series 0, okay, it is C. Then I produce my design. So I'm going to run this line here, RDesign. I run it, okay. Then I want to see what R has done in RDesign. So I run RDesign and it produces the sheet down here. So I want R to pick only the field book. RDesign may have so many things which I don't need, so I want it to put it in a field book. So I call it book is equal to RDesign, and within RDesign, pick a field book only. So I run that, and head is field book. Now, if you want it written on a CVS file and open it in Excel, you go and write the right command again, just like we did before. And you will produce this in Excel. Is that fine? Can I see in the chat, ladies and gentlemen? Let me see comments in the chat. Okay. Yes, can we, okay, yes, people, if you don't have the script, please write down in your computers, use the script I have. Yes, I can see some people need time, so I'm giving you 2 minutes. It is right here. Please write it down and try it on your laptops and see that you do not have an error. If you have an error, write it in the chat. I will pick it very fast, or Q&A, Helen will pick it very fast. Okay, so 2 minutes I give you to write the commands. Okay, I am also going to paste these commands in the chat. Remember, if there's something that is puzzling you, just Google it. Please scroll down. Let me paste it in the chat. Okay. So I pasted the whole command. Or they are saying go left. I pasted it in the chat, the commands, but let me go left. Seri equals 0. Okay. So let me scroll back so that had gone. So please. Okay, can you please log in back? The internet had disappeared. It is back. Okay.
No, there was no interruption, Prof. We are still on, so it's fine. You go ahead.
Okay, thank you. Okay, thank you very much. Okay, I've pasted the commands in the chat. Please pick them very fast so that we can go on. I'm giving you 1 minute to do that so that we can continue with the next part. Okay. Okay, so let's continue. You can do that in your free time. And if you get a problem, please, we shall have office time, office hours. I'll be there with Helen. We can answer your questions. And we are going to send out the Zoom link for office hours. That's 2:30 for people to join in and we solve your problems. Let's go to the next. So pay attention to the next part, please. Let's go to the next one. Let me check the chat before I continue. I've pasted the commands again in the chat. So please, can we now pay attention to creating a randomized block spreadsheet? But if you feel you don't need this and you can do it on your own, since we've already gone through the first part, then we can leave it. But let me go through it just to help others, okay? So here we need library Agricola and Due, which we can just run. So if you've already installed them, make sure they are loaded. And so we are going to do a randomized block design. So it's also not so difficult. So here we have treatment 1, 2, 3. And you can see that what we had before. We are not putting the seed here. The seed is in the design. You can see it right here. So let's go step by step. We have treatment. Here we are specifying that these are the treatments, 4 treatments. Okay. And then out design is an object. You can actually name it anything. You can call it a randomized design. Okay. And we are saying that this object out design is equal to design.r design. With the treatment, and then they are replicated 4 times, and this time the seed is equal to 11. You see, we've been asking about the seed. You can put n number. It's just random generation. Remember, these commands are picked from Agricola. So let's run the first part, and then the second, which I've already explained. The third is RCB is the name of the object, is equal to out design $book. So I'm saying that I want in out design R to pick the field book, and I call it RCB. So I run that. Then levels are the blocks. Now I'm bringing in the blocks. Levels in bracket RCBD, $, pick the blocks and name them, put together. You're going to name them Carnation, Daisy, Rose, etc. So what was the aim of this design? There are 4 blocks of different flowers. And we want to know which flower withers first. You know, we buy flowers, put them in the house. So I want to know which flower withers first. So this is the experiment which was being set out. So the blocks are the different types of flowers. We have carnations, we have daisy, we have rose, we have tulips. So in this command here, we are telling R that our blocks will not be 1, 2, 3, 4, but they are going to be called carnation, daisy, rose, and tulip. So let's run that. And then we want to print out the object. So let's print it out. So it brings, let me also bring it here. Where is our R? So there we are. We have the plots, then blocks. You can see they are called carnation for treatment. So within each block, the treatments have been randomized to 4 plots. So if we go down to daisy, block daisy, treatments have been randomized. Rose, they've been randomized. Tulip, they've been randomized. Then we are going to go and purchase these flowers, put them in a room, same room, and then subject them to a treatment, which is just a liquid, different types of liquid, water, tap water, vinegar, another type of liquid, and then put them out there to check which type of flower withers very fast. Okay, can I see in the chat whether I should repeat myself or, so what does RCBD mean? RCBD is randomized complete block design. It is a type of design whereby now you know that there is variation among the flowers, the different types of flowers. So you're using type of flower as a blocking factor, so that within each block there is homogeneous variation. And the only problem you are worried about is the effect of the treatment. If you do not block for type of flower, then you're going to get results that are confusing. They will confuse you. You want to know whether it is the type of flower bringing problem or it's the treatment. So when you block out type of flower, that variation has been accounted for, And now you are left with a variation due to the treatment, which is the different types of liquids that you're applying in the jugs to the different flowers. Okay, so in each block we have 4 jugs. We put in carnations 4 times, and then the first jug we have water, the second one we have diluted vinegar, the third one we have diluted Dettol, the third one we have any other liquid we think of. So we want to find out, when you buy flowers, carnation, and put them in water, put them in vinegar, which liquid helps them to stay faster, so that you don't go back to the shop after 2 days, you're buying flowers. Okay, that is the aim of the experiment, is to find out which particular liquid you should put in the jug. When you go to the market, you buy roses. Should we put plain water? Should we put some vinegar? And then the vinegar, we have the white vinegar and the colored one. So those are the different types of treatments we are applying to the different roses. That is the background information about the experiment. Now, block. What does block mean here? That's another question. I have said that RCBD is randomized block, complete block design. When in your experiment, you know that the different flowers take different times to wilt, and you can't control for differences in species of the flowers, we make them blocks. We group them in groups which are similar. So carnations have similar variation because they are carnation by species. Daisy is a block with similar variation. Rose are blocks with similar variation. So because the groups have similar variation, they become blocks. But if you move from carnation to daisy, they are 2 different things, because they respond to water, vinegar, and other treatments differently. So we block out type of flower, so that type of flower does not confuse our treatment. And when we collect our information, we also are not going to be confused. That's what they call a confounding factor, or a factor which is lacking. It's in the background disturbing your information. So blocks are used to take control of the variation, which you cannot control as an experimenter. Okay, so the use of blocking is to control variation in the experimental study, which you cannot explain with the results. Okay, so once you divide your block into different groups, then you've accounted for that variation. On the other hand, I can give another example. If you are in a field and you find that in the field you have some places with dark green grass, light green grass, then medium green, then light green, that will tell you that those colors are varying due to the differences in fertilizer. So you're going to block your field according to color of grass. Once you block that variation, which you cannot control, even when you perform your experiment, you have done blocking. And within each color, you now section it into plots where you apply your treatments. So now your problem will be the treatment you're bringing, not again the color of grass. I hope this is clear. Can we see yes or no in the chat so that we move on to another thing? Is the blocking clear? Somebody is saying, how do we block on a slope? There I have to demonstrate because I don't have a... Okay, let me move to my chart again. Okay, ladies and gentlemen, pay attention to the chart. I am going to stop sharing so that we only have the chart. And there we are with a chart. So if you have a slope, assuming I have a slope, this is my experimental study, that is the slope. and the slope is due to this hilly place, so our variation is going down. So at the top here, we find less fertility. Can you see? And then in the middle here, different variation of soil, and the soils down here are more fertile. So blocking, how do we block? First of all, we can pick soil samples, label them, take them to the laboratory to find out whether there are differences in soil fertility. After we find the differences, now we are going to go to the field, and knowing the direction of variation, you can see it is decreasing as we go down. Our blocks are laid perpendicular to the direction of variation. The blocks are laid perpendicular to the direction of variation. Okay, so you can see at 90 degrees, I lay the first block. At 90 degrees, I lay the second block. At 90 degrees, I lay the third block and the fourth block. Then after that, I now put my plots. Then these are the plots, so I put treatment A, B, C, like that, randomized. Okay? Then afterwards, I go in and collect information. So in this experiment, you are worried about the effect of the treatment, not the variation due to slope. If the slope is not a hill, you use the altitude. You can measure the altitude and then you divide your area according to the different altitudes, and areas with similar altitude become the blocks. So a block should have similar variation. And within a block, you have the different plots where the treatments are applied. So let me see in the chart. Is blocking clear so that we can go to something else? Although we are going to talk about it when we come to analyzing data. Okay, that's great. Okay. Sorry. Okay, ladies and gentlemen, let me share the screen for R. Somebody is saying, what is fertility? Can I have somebody in the participants, can you post the definition of fertility in the chat so that somebody knows what fertility is? What is fertility? Post the answers in the chat as I share the screen of R. Yes, the blocking factor is fertility along the slope. Okay, people have answered what fertility is. Okay, so I hope ability of the soil to produce nutrients to plants. Okay, thank you. Okay, let's go on then. So now I have another question for you. Is generating a randomized complete block design using R okay? Can I have a yes in the chat so we can move to the next section? What can you do? Do we need a break? Okay, do you need a break? Should I give you 5 minutes break? If you need a break, say yes. Some are saying no. Most people are saying yes. Yes, but make sure you keep time. It is 12:53 in Uganda. So at 1:02, let's come back. 10 minutes is a lot of time. We only have 1 hour left and we have a lot to do, interesting things, which I don't want you to miss. Go and visit the washrooms or the men's and ladies' or you want to buy airtime, please do that. Thank you so much. Let me see you at 12:05. Okay? Thank you, thank you. Let's go. Let's go. I mean 1:05. Sorry about that. Let me type it in the chat. Come back at 1:05 p.m. Please keep time, keep time. We want to move at the same time. Thank you for being great participants, and come back with more energy as you had in the morning so that we can. Okay, so I'll share the commands. I thought I'd shared. Okay, there we are, the commands. Let me share the commands. I don't know which part you want to see, probably what we've just done. Okay, so those who are not going to visit the washrooms, you can practice the commands. And if you feel that you don't need to practice, that is also excellent. It's okay if you're comfortable. Okay, so I will also go for a break. Thank you. Ladies and gentlemen, I have given you more than 5 minutes. Can we start? Is everybody back? Can we see in the chat people saying yes, they are back so that we can start? Me not hearing. Okay, let me see whether there's a problem. Can you hear me? Yes, okay. If you can't hear me, say no. Okay, okay. No sound. Maybe it is your computer. Make sure you check. Let me check my sound button. My sound is okay. It's up to 93, which is the high, almost very high. Okay, okay, thank you very much. So let's start. We will do just a simple recap of the issues which have come up. You are loud and clear. Great. Excellent. Okay, thank you so much. I hope you had a nice break. Okay, the last time, before the break, we were generating a field sheet with a complete, randomized complete block design. Now, in the chat, I've noticed people saying, what is a seed? What is a series? What is so? Pay attention to my consoler. I am going to type help. I'm typing help, and in bracket, I put in design. I'm typing design dot. Now it brings you what you want to say. I'm going to say RCBD is what we've been dealing with. Then I enter. So when I enter, you go down here in the extreme bottom right. I'm going to remove this. So in this extreme bottom right, you see my cursor. It has definitions of what we've been using. TRT is treatment. R is replication or blocks. Series, people are asking me, what is series? Number plot. So it's going to give the plot numbers. You see, I put series equals, actually I never even specified series, but automatically once you say design.rcbd, it is going to generate the series, okay? So you can see in my, if you want the plots to start from 1, 2, 3, you can say series equals 1 or 0, then it will start from 0, 1, 2, 3 up to etc. So because I didn't specify any series, you see that in the RCBD, the one that I generated, I'm starting with the plot 101. So I didn't specify the series. So that is the definition of series. It's the number of the plot. The seed, they've said it's a seed. It's a command for random generation where you're starting from. Kind, these are things that embedded in the command design.rcbd. There is also kind, that is the kind, the method of randomization. Then they're asking, first, true or false? Do you want to randomize or not? You put true, you want to randomize, and then randomization true, yes, I still want to continue with randomization. Now, you can see here they are giving you the kinds, the types and methods of randomization. In here, we used super duper. I didn't choose it. The person who designed design.rcbd, that is Philippe et al., used super duper, so I didn't have to change it, okay? So you can come here and use any of these ones, okay? Then value, parameters, sketch, the field book, you see? Remember when we produce our RCB, which is the object, it has all these things. That's why when we want to print out, we want only the field book. We don't want all these design parameters, the sketch. We are picking out the field book, which we print out. Then some people seem to be confused about the object. I will use the first line as an explanation. Okay, so an object is a name you give to a command so that that command produces whatever you're instructing it to do in that object, stores it in that object. It's like, for example, let me use, it's like you go to buy some things in the market, and today you're going to buy only vegetables. So your name is going to be vegetables, and within vegetables, you're going to buy cauliflower, you're going to buy red and green, you're going to buy tomatoes, onions, etc. So all those are put together in vegetables. So it is a name. You can use, actually you can put your name. I can put Susan, and it still produces my treatments named Susan, because it is just a name. It has nothing to do with the package. So wherever you see an object, the first part here is the object. It's like a name you're giving to this command here. The name treat is equal. This is what you're putting together. C means put together. 1, 2, 3, 4. So we are saying R, put together these treatments in this file. Let's call it a file for ease of understanding, or object called treat. So that is the definition of the object. Okay. So we are going to go again. So for the rest of the thing you will try out, it is also generating a CRBD, but here we are using things like zigzag. Those things you can actually put help zigzag and you get the information. So if you want to use this part here, the second part option, I have just put it for you, where I'm specifying everything in the function tr, r, a series, seed, kind, everything is there. So you can use the same thing actually to produce the design that you had before, so that you can try out in your free time. And if you get any query, since you already have this script, you can come back and ask the question. But let's go to data exploration. So we finished setting up our field book. We are going to go to the field, and I'm assuming I'm going to do forestry. So I've gone to the forestry field. I have collected data on the forest. I'm looking at the growth of these mahogany species, and there are 4 of them, A, B, C, D, and they have stored my data in a file called forest. So the first thing you do, what we are all going to do, is to get our working directorate, and also set our working directorate. Can you hear me? Some people are saying they can't hear me. Can you hear me? Okay. Let me check the chat. Okay. Thank you. Okay, let's continue. Now we are going to do some exploration. You remember Dr. Helen showed you exploration of a data set that comes from the survey section. How about if we have an experiment data set? What do? So that's what we are going to do right now. Okay, so what I'm saying is that we are going to go to session window. So the easiest way to set our, is to go to session. If you can see session, it is on the menu bar under R Studio. So if you will see file, edit, code, view, plots, then you will see session. So if you click session, the next thing you see is set working directorate. So click set working directorate and then choose directorate. So session, click session, choose set working directorate. The arrow will actually bring 3 things, but we are going to choose directorate. So once you click that, then it takes you to your documents. In the document, you just click documents, and produces lots of folders. You scroll to where you're storing your R things. So mine are in slides, you can see. So you don't see anything but you're setting your, once you click OK, you will see in the console, it will say set working directory and shows you the path where all your data is stored. So I'm assuming that you got this data set called forest.csv and you've put it in a folder which you have to set as your working directory. So please do that in 1 minute so that we can continue. 1 minute, please. Are you done setting your working directory to a folder where did not receive which document? It is called forest.csv. It is on the drive, done. Yes. So if you've not received, Helen, can you paste that file in the chat? Helen is going to paste the file in the chat, so you can just download it and get it if you've not received it, but make sure you put it in the folder and set your working directory to that folder. So the document has been sent, download it. It is forest.csv. That's what we are going to use. And make sure you direct your R to that working directorate. Otherwise, you're not going to be able to see it or use it. Okay. Okay, from that, is it okay? Should I continue? Should I continue? Okay. Somebody is saying, whoever said no, please make sure you've set your working directorate because you won't be able to do anything else. Okay. Okay. We are going to go and write our first command. We've already gone through this. We are going to import the data set called forest.csv from Excel because it's an Excel file. Okay. So what you do, you give it a name, which you're going to use in R. So this name, I've called it forest. And then I say forest assign or is equal to read that CVS file, which is in quotes called forest.csv. So that command is what you should write. Let me just scroll. There we are. This is the command. Maybe I put it in blue. So write that in your script. I repeat myself, make sure you set your working directorate to where that forest.csv is. Otherwise, you won't be able to go ahead. Okay. Is that okay? Should we continue? Let me see some yeses in the chat so that we can continue. Ladies and gentlemen, because we are going now to go to other interesting things and I don't want to leave anybody behind, okay? What is our current topic? Exploration of data. That is what we are going to do. We are going to explore our data. This time the data is from an experiment setting, okay? Oh, somebody says they didn't receive the material. We've just pasted it in the chat. And Helen will paste it again, but we are not going to give you time. You will follow, so pay attention, then you do it later, okay? So please pay attention, we are going to start. So make sure you write this command, forest, assign, or if you don't know this sign, just use equals, read.csv in quotes, forest.csv, okay? Then when you're there, run, click run. If you see any red, it means that you didn't direct R to that working directorate, okay? Now, we want to see what is in forest. So just type forest and click run. So in the console, you will see the numbers, forest. So even on the environment part, you can see forest. So I'm in the environment, I'm going to click forest. So when I click, it appears where my script is supposed to be. And what does it have? It has species and growth. The species are 4, A, B, C, D. Growth of those species. So I've already performed the experiment. I've collected my data. I have filled in the data. Okay? And our data has species and growth. Growth is the response and species is the factor. Because it's categorical, it could be numeric, but is a factor. It is the independent variable, and growth is the dependent variable. So I'm going to close that. You see on top here where there is experiment in red, I close it so that I can see my script. So I close that, and the script comes back. So we had printed out our data to see how did I write the variable names, because if you write them with capital, you come here, write them with lowercase, you're going to get red. We don't want to get red. We are tired of red. So we want to go red, blue, 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 blue. So make sure you know what is in your data set. So the first thing we do, we can find out whether species is called a factor. So I remember yesterday they taught you that, so maybe I don't go through it. Let's go here. We want to make species a factor. So my object is still species. I say species is equal to a factor. You can use as a factor or factor. In bracket, in the data set forest, I want you to pick species and convert it to a factor so that I can be able to use it for analysis as a factor, not as a text. Okay? So I ran that, and it is there, it has worked. Has it worked for everybody? Let me see in the chat. You might have an error. Which error do you have if you have an error? Okay, so I close out. I see most of you are saying yes. Then I want to check whether R really converted species to a factor. So I put class in bracket species. So I run that. And it says, yes, species is a factor. In the console, you see factor here. Then I want to summarize growth. Growth is my response. I want to summarize. Summary gives you what is in your data. It gives you the mean, minimum, and maximum, etc. So summary in bracket, the file name, $sign growth. So I'm telling R, go to the file called forest, pick out growth and summarize it. Okay, then let's run R. There we go. So in the console, if you look at your console, you will see minimum, first quartile, median, mean, third quartile, maximum. From those magnitude of values, we know that minimum is the lowest value. First quartile is 1 of 25 of n. Then what value occupies that position? Median is the value which occupies the middle position of your data after you've arranged them in ascending order. Minimum is the average. You total all those values and divide by the total number of observation, gives you the minimum. So when you're writing in your project and you produce these summaries, don't just leave them there for your professor to interpret. Just like I was saying, you said the minimum growth was 11.42. The units should be either kilograms or whatever units you're using. And the average growth was 26.82. The maximum growth was 43.32. The next thing you want to see, which species gave you the maximum growth. Okay? So we are now in our data, we are summarizing it. The other thing I forgot to mention, when you get data as a student, that's how I was, I don't know about you. I would want to run my regression first before I do these plots and box plots and summaries. I want to see the model. Now, you have to cool down and do these descriptive statistics to see what is in your data. The descriptive statistics helps you to know, are there differences in the different species? Are they growing at the different rates? If yes, then how are we going to confirm that those differences are significantly different? So the next section is we are going to use the function summarize by species. So here we have library. If you've not run it, I've put it here so that you remember to run that library. Otherwise, you may not be able to write this command. So quickly type in library dplyr. It helps you run by group command. So you see that I have this percentage greater than percentage. R cause this pipe. Instead of writing individual commands, it would be a command run. It's going to give you the output. So those percentage greater than percentage, it is just a pipe you're passing through your command so that you don't write the commands separately. So you don't need to get a headache about those ones. If you think you want to know the meaning again, type help in the console and put in that symbol. It's going to help you know what it is. Let's run this command. There we go. I wanted to summarize my data by species. And in the summary, I needed only mean growth. So there it brings my mean growth. Now, I want to give you 2 minutes to run the same command on your computer. And if you get an error, type the error in the chat. Your voice is breaking. Okay, let me get closer to the laptop. Is it clear now? Somebody says, I got an error. I don't know what error you got. Some done running, error in forest. Okay. Now, if that function is not working, did you install dplyr? It is a package which allows you to put the pipe. So install dplyr and then load it, and it's going to work. Now, also some people did not put the greater sign between the percentage, so it should be percentage greater sign percentage. So correct that, please. Now, if it says unexpected help, make sure you've installed dplyr. Okay, thank you. Install dplyr, then load it. Okay, you have, yes, you have greater than after forest. It is not supposed to be greater than. You don't need to assign anything. If you look at the commands in R, it is forest, the pipe, percentage greater than percentage, then you go to group. Error in loading Excel. Oh my dear, you really verify, you didn't. Now, if you have error in loading Excel, close your file of forest.cvs. Close it. Then, yes, here I have an error. Isaiah, make sure you put mean. You didn't put mean. You please look at the command very carefully. Look at the command. I have almost exhausted the comment, so I want us to focus to the command. This is the command we have. This is the command we have. There we are. That is the blue highlight is the command. Look at it. Library in bracket dplyr. First run that function. It's the one going to help you use the pipe. Then forest is the file name. Now there is somebody who says he cannot access forest. oh, there's something wrong with forest. If the Excel file is still open, it's not going to allow you open it in R. So close it first, then you set directorate to that folder, and then you start running forest. Then if you've written forest greater than, then the pipe, it's not also going to work. So eliminate the greater than sign between forest and the pipe. Now, some people wrote summarize growth equals growth. So you've not specified what you want in summarize. So you put mean in between equals and growth. So follow this, follow this and run. So 1 minute, let's see what you have. 1 minute so that we can move on. We only left with 29 minutes and we want to maximize our time. Okay? Maximize with efficiency, not just going and finishing. Okay, ladies and gentlemen. Okay, let me see the chat. Okay, it says error in object install. Deployer, the spelling is wrong. So make sure you use this the correct spelling. Deployer is DPLYR. There is no E between Y and R. That's why they couldn't find that function. Okay, so can we continue? Ladies and gentlemen, the only thing I want to do is to interpret the results. So if I can see yes, then we go to interpreting the results. Okay. Let me see more response. What are others doing? Let me see more. Interpret, please. Okay. Can we have more responses? We don't want to leave lost. Oh dear, you will come during the off hours. Anybody who has a problem now, come during the office hours. We can sort you out, but allow us to continue, please. Please. I can see two people have problems. So if you allow me, let me interpret the results. So focus on the consoler. Now, those who don't have results, look at my screen. Below here where there's consoler, there are results. We have species A, B, C, D, and the values we see is average growth. Now, I can pick this and put it in my project document, which is the Word document, create a nice box, put in species and mean growth. And now I talk about this box. I said the lowest species, the species with the lowest growth rate is C, and the species with the highest growth rate is B. The magnitudes look different, so we would like to confirm these differences using in a statistical package. So I have a question for you. If we want to find out that the mean of A, B, C, D are different, what statistical test can we use? Can we see the answers in the chat? What statistical test are we going to use to test if overall there are differences between A, B, C, D? Let me see the answers. Okay, great, great. I can see you. Excellent. Let me see more answers. Okay. I'm going to pick out those which are unique. Okay. Okay, great. Thank you so much. Okay, let's go with those. Oh, I've seen another one which is so interesting, paired. Okay. Oh, okay. I am going to comment on a few answers. Okay, now let's focus on our data. The data we have is ABC. We've seen that the descriptive statistics says that these values are different according to the magnitudes. Now I asked, what statistical test can we use to find out whether overall there are differences between the growth rates of these species? So people said ANOVA, which is excellent. Why? Because our groups are more than 2. That's why ANOVA is correct, but not very correct, because there's ANOVA one way and ANOVA two way. Now, it should be ANOVA one way. Why? Because we only have one factor, species. If we had another factor, for example, type of soil, then we would use ANOVA two-way. So the most correct answer would be ANOVA one way because we have one factor, species. Now, somebody said correlation. No, not correct, because correlation is used to find out about relationships. And here we want to look at the means. We can't correlate means here, unless if you have another column of means. For example, you have length. You want to find out whether the mean length is correlated to the mean growth. Does it make sense? You think it makes sense? No. Doesn't make sense. We correlate the raw data. So here we are looking at means. We don't want to get correlation of means. We want to get correlation of the raw data. Is there a correlation between growth and length? So if we are interested in correlation of the mean of the raw data, that means you have a lot of data and it's going to be summarized by so many things that you have more than at least 30 units of observations which you're going to correlate. But remember, we only have 4 observations here of means, so we can't do correlation. For now, the appropriate test statistic would be one-way ANOVA. Now, somebody said LSD. Yes, that could be, but not now. After we've performed our analysis of variance called ANOVA, and we find that overall our p-value is significant, then we want to find out which particular mean is different from the other. Then we do LSD, we do Turkey. Okay? Somebody said paired t-test. No. Paired t-test, we said yesterday that because we were collecting data from the same plant, we collected from plant 1, we collected weight of the seed bottom and top. So these 2 values are correlated, so we use a paired t-test. So that is to mention in passing. I hope that is clear. Okay? Now, let's continue. We are doing descriptive statistics, and when we have data from experiments, we don't want to run things like percentage. Now, percentage of what? We don't want to do those ones, because if you're going to reduce your growth data into percentages, that means you're going to group it. So the best thing is to get means and see the average growth, because you have a continuous variable. If you want to do percentages, we have to create groups of growth to do percentages. So when you have a certain type of data, you should know how to summarize it. So percentages would make us lose information under growth. So we leave it aside and use means. We can also produce standard deviation, range, minimum, maximum. Those are appropriate. When we come to constructing box plot, plots or graphical displays help you to understand the trends within your data. In this case, we are not looking at a linear trend or etc. Now we want to know about means of these groups. So we are going to construct a plot which is appropriate for means of groups, which is a box plot, because it's going to compare between the groups. We will also look at the variation between the groups. Okay? So when you're stuck and you don't remember what I've said, Google. Mr. Google or Miss Google, I don't know the sex of Google, maybe he or she, whatever, will tell you something. You just put in descriptive statistics for continuous data. Then a lot will come up, depending on your objective again. Because under continuous data, it can say scatter plot. Is it really relevant here? No. So it will also give you box plots. So you have to know the type of summary and the type of data. Okay, so that helps you. Good. Why use one-way ANOVA? I said we use one-way ANOVA because we have one factor, species. If there was another factor, for example, type of soil, that means we also want to find out, does growth vary with type of soil? So we use a two-way ANOVA. But in this case, we have only one factor, which we are investigating, and we are going to use a one-way ANOVA. Okay, but we are not yet there. That was just to mention in passing. Okay, now let's construct a box plot. Okay, levels, factors. Okay, there are questions. What are levels? What are factors? And what is continuous? Okay, let me start with continuous data. Continuous data is obtained by measuring. For example, growth, you have to measure it in terms of diameter and length, and then you get growth. Now, continuous data could range from -infinity to +infinity. It has decimal places. For example, your height, you do not have like 5 feet, you must have some point, or 6 feet, 0.3. So that is labeled continuous data. There is another type called discrete, meaning you have countable values. They have 1, 2, 3, don't have decimal places on them. So that is continuous data. Now, what was the other question? Okay, which one? Oh, levels and factors. Now, species is the factor. It has 4 levels, A, B, C, D. Is the difference clear? We could have another example. And let's say quality. Quality is the factor, and it has example. We could have another example. Rising time for bread. We had 35, 45, and 40. So those are the levels. Okay? But the factor is rising time. So that is the difference. Okay, let's continue. Yes, weight and length are continuous. Okay, let's construct a box plot. Now, a box plot, the command you use for constructing a box plot, if you can pay attention to the script, we have box plot. Growth is a function of species. You see this squiggle? I don't know how to demonstrate it. I think you can see my hand. That small squiggle here, it is a function of follows species, comma, the data is called forest. The x-axis is called species in quotes. The y-axis is called growth in quotes. What else? That's it. So let's run this and see what we see. There we go. Magic happens. Not really. Okay, there we are. Magic has happened. No longer numbers. We have plots, box plots. That's what we asked R to do. Okay. We have our species. We said you should label the x-axis with the species. So our species are A, B, C, D. It picked this from your forest data set, and this is the growth. Now, if you think that the growth of these species has not been captured, you see your y-axis here? You can actually tell R that the limits for growth should be from 0 or from 15 to maybe 50, so that it captures everything. So those are the specifications which were being mentioned by Dr. Helen. Let's focus on this diagram. Remember, you can copy, we shall see that later, and take it to your Word document and start writing around it. Then the other thing I want to mention is when you take a plot in your Word document, the title is placed below the plot. Don't put your title on top. Y is the vertical axis on the graph here. If you look at growth, the vertical axis is Y and the x-axis is the horizontal one. Now, put the title of the figure below the figure. That is the standard way of presenting your work in a project, in a paper across the world. Okay? So, I don't want to see you putting your titles on top. Even if you've told the command to put the title on top, you can actually erase the title. Put it below. You say figure 1, box plot of species, box plot of growth by species. So the title should also tell the reader what is in the plot. I have zoomed it. Can you see the plot, or can you see the zoom plot, or I have to share it? Okay, let me share the plot. Let me share the plot. Oh, they are saying yes, they see the plot. Okay. Let me share it. There we are. Okay, there we are. Thank you about that. Okay, so we want to interpret about the plot, because we do not want to draw these plots, paste them in the Word document and leave them for the supervisor to understand. No. That's not a good way of writing your project. You must explain what you present. If you don't know, don't present it. You have to understand what you're doing. Okay, so first of all, a box plot is a 5-point summary. It consists of the minimum value, which is the lowest part. If you look at this second box plot, this is the minimum of that group. The second part here is the first quartile. The line, the dark line here, is the median. This boundary here is the third quartile, and this is the maximum value. So all these box plots have 5-point summary. The middle line is the median. A box plot with the highest median will have its line above all the others. You can see that species B has the highest median growth. If you want to call it, you can say the highest average growth, because median is a measure of central tendency or a measure of average. Now, we can also look at the minimum. Which species has the lowest growth rate? It is species C. So if we are advising farmers which tree species to grow in their farms, we would advise them to grow species B. We would tell them species C is cheap, but it's going to take a longer time to grow. So we advise them to grow. Now, these are the differences we want to confirm. Is the average growth rate of B significantly different from D? Is it significantly different from C and different from A? But we've already observed that the box plot are showing us that there are differences in average growth rate. We also can tell the distribution of the data. If this line is in the middle of the box and this side is outside, we call that normal distribution. I'm going to repeat. If this middle line, the dark line, which is the median, is in the middle of the box and this side is equal to this side, then we find that or call that normal distribution. From our box plots, we do not have any normal distribution. All of them are skewed. Now, where you see the longer part of the box tells you where the data is skewed to. You can see that A here is skewed to the right. B is also skewed to the right. You can see the longest part of the box clear. C here is skewed to the left. You can see that the largest part, you can see from median going up to the minimum, is the longest part. So it's skewed to the left. D is skewed to the left also. Okay? These points you see are called outliers. Now, what are outliers? Those are values which are so different from the others that sometimes they are wrongly entered, sometimes they are true values of what has happened in your experiment. So you need to leave them in, don't remove them. So go back to your data and see, did you enter anything wrongly? If not, then it is a true outlier to be in the data set, and you analyze, it's going to disturb your parameter later on. Okay, so we've seen that box plots are used to compare between groups. So we've seen that when we are comparing, we look at the average, which is the median, and our median shows us whichever has the highest median has the highest growth rate, which is B. And then we said we can look at the distribution. So if the middle line is in the middle of the box and the left is equal to the right, then that distribution is called normal distribution. Okay, I have finished with the interpretation. Let me see the chat. Tell me if you don't understand. Voice is lagging. Is it possible to put a threshold line? No, we don't need a threshold line unless if you have a particular median in your data set, but for now, no, but it is possible, yes. Okay. Somebody is called, how about SD? SD is standard deviation. We haven't talked about it. We are going to see it. Explain the different parts. Okay. Missed, the voice is breaking. Okay. Repeat the first part of the explanation. I need to understand the box plots. Okay. Error bars, we haven't talked about them. We'll talk about them. It's going to be your assignment, ladies and gentlemen. You're going to copy your box plot, post them in the Word document. Tomorrow, it will be the first thing I'm going to ask whether you learned how to post it in a Word document. So what I'm going to do is to repeat what I've just said. I might not repeat as I said it before, but it will be the same meaning. So I say that we choose a box plot to summarize our growth data from an experiment setting because I want to find out, are there differences in average growth rate among the species? So if they are there, what can I use? We looked at the means, we saw the differences. Now we want to use box plots. Now note, if you've presented the means, don't present the box plot, okay? Because it's the same information you're presenting. So you choose, either you want a table of means or you want a plot, whichever you feel you want, so long as it is telling you the same message, okay? Or on the other hand, in your project, mix match. If you have a plot here, you can have a table next. And remember, the title of that table goes on top of the table. The title goes below the figure. Okay, now let's talk about the box plot. We say that for us to know whether these box plots have higher growth rate, we look at this black line. The black line is the median. The median. So if we look at this black line, the species with the highest black line is B. So we know that species B has the highest growth rate. And I said, if you're making recommendations, then you would recommend to farmers to grow species B. But also look at the biological functions of species B. Probably it grows very fast, but then it breaks, you know? So as we recommend to farmers, we have to balance statistics and biology, okay? Then I say that even D has higher median. So it's also a good species. Now, we want to find out if species A has a higher median. Is it different from A? Is it different from C? So there, we can now test using any other statistical test. Okay, 5-point summary, descriptive summary. The minimum value is the value which appears here, where my cursor is. Then as you travel along that vertical dotted line, the boundary here signifies the first quartile, which is obtained by calculating 1/25n. That gives you the position. Arrange the data in ascending order. Look for that position. The value there is the first quartile. The next one is the median. It is the middle value when your data is arranged in ascending order. The third one is the third quartile. 3 out of 4 or 1 out of 75 is the same thing. 3 out of 4 of n gives you the third quartile position. And then look in your data. When the data has been arranged in ascending order, which value is occupying that position? Then plot it. That is the third quartile. Then move along the dotted line. The last value is the maximum value. That is the box plot. Then we talked about the variability, the distribution. We said if this black line is in the middle, then and the left is equal to the right, then that data is normally distributed. Otherwise, it is skewed. Skewed either to the left or to the right. So the top part is the right part and the bottom is the left. When you flip your graph horizontally, so that means growth will be on top and then you tilt it like this. So the graph here will be the other way around. So this is the left, this is the right. So if we look at A, the right part is bigger than the left. So it is skewed to the right. C is also skewed to the right. You can see the tail is longer this side. When you draw a line along this plot, you will see the tail is longer on this side. Now C is to the left. You can see the bigger part is to the left. D is also to the left. Okay, so that's all about the box plot. So let me see in the chat. Is it okay about, oh, I'm not seeing your screen. Are you sure? Are you not seeing the screen? Okay, thank you very much. It is okay, it is okay. D is not clear, D is skewed to the left. You can see that the longer part, if you compare this part from the black line down and this part, this is bigger, so it is skewed to the left. Okay, so I'm going to stop sharing the box plot and I'm going to go back to the commands. We have 2 minutes. In 2 minutes, we are sharing. I'm going to stop sharing. I have stopped sharing. And my colleague, Dr. Helen, is going to share some questions. Is going to share the training support link now. So in 2 minutes, let's share the training support link. Please log on at 2:30. We will be available to help you. Okay. So thank you so much for being very excellent participants. You've been so interactive, you've interesting and up to date. You know, I am so happy that you are following. We see you during the training support of hours of the YouTube, and enjoy your lunch. Make sure you relax, even if you've gotten the reds in the R, relax so that your head freshens up, and come with questions during that link. Thank you so much. I now leave the meeting. So Dr. Helen, please share the link so that it can be viewed here. I have stopped sharing. Thank you.
Okay. Good afternoon. Hope you've enjoyed the Okay. You can hear me?
Yes, we can.
Okay, good afternoon. Hope you've had an interesting session in the morning. So I've shared the support link in the chat, and we'll be waiting for you at 2:30 such that we clear different issues that might not be clear to you, such that when the moment we get to tomorrow, we're on the same page because we are going to still cover different things. All right, have a good afternoon. See you at 2:30 for those that will attend the office hours. Thank you. Please copy quickly before the webinar is closed. And I encourage you to still check the link for the training materials because we are posting everything there. But at the same time, we still try to send on your emails. Okay, you can take a screenshot of what I've shown such that they don't get you off guard in case the webinar is closed anytime.
East African time.
2:30 East African time, just count 30 minutes from now. That's when we'll be within the office hours. Okay, bye-bye. Yeah.